Hello, my dear lovely students. How are you? I hope you are quite well and your study is going very fine. Today, we are going to discuss the chemical properties of haloarenes. Once you understand perfectly, please like, share, and subscribe the channel. We are going to describe this whole logic. See here. That first is that wurtz fatigue reactions. Those fatigue reactions. Second, we have fatigue reactions. Fatigue reactions. Third is that, and Ullaman reactions, and fourth is that frankland reactions. Frankland. Students, these two, Ullaman and frankland, is not a NEET syllabus. So NEET students only watch this two video, that the mechanisms, and the JE students all you cover this. Okay. Now first we go to the wurtz fatigue reactions. As you know, that the wurtz fatigue reactions, what will going to be happen here? Students, see that wurtz fatigue reactions is here, that CS3X, that is the wurtz reaction, and the 2Na plus X, here is the benzene, aryl halide, this is the fatigue reaction. That is the fatigue part, and that is the wurtz part. And when we take the dry ether, the compound is going to be formed at the toluene, or alkyl benzene will form, whatever you will take here. Okay, that the things will happen. Now the question is that why we take the dry ether? Students, see that dry ether is non-polar solvent. Non-polar solvent. Correct? So when we take that non-polar solvent, usually what is going to be happen, that is non-polar solvent, non-polar aprotic solvent. Non-polar aprotic solvent. This is the non-polar aprotic solvent, right? Aprotic solvent. Okay. So it is a sodiums will not react with non-polar aprotic solvents. Correct? Sodium is highly reactive. So the why we'll take the highly reactive substances? Because otherwise reactions will not be proceed. And second, why we'll take that non-polar polar aprotic solvent? Because we need to control the reactions. So since sodium will not be reactive with the non-polar aprotic solvent, therefore we use, otherwise when we take the polar aprotic solvent, what happens? Reaction will be very fast. So reactions will not be proceed like that. Therefore we'll take the non-polar solvents, aprotic solvent. Okay. Now see what is going to be happen here. The two mechanisms will work. Either you can obtain this alkyl benzene by organoalkali mechanism. Correct? And that is the ionic mechanism, basically. This ionic mechanism. And second, you will move to the radical mechanism. What happened? This is the radical mechanism. So either this mechanism or this mechanism, radical mechanism, through radical mechanism, you can obtain the alkyl benzene. So see what is going to be happen. 2 mole sodium will take. Sodium, 2 mole sodium, we release the 2 electrons. Correct? So what happens when we take the alkyl halide? I go through the radical mechanism. So that the 2 electrons, the 1 electrons, what happens? Halide will move, and then the CS3 cations plus X negative will form. Then 1 electron will take that methyl radicals, that methyl from the methyl radicals. Similarly, when you have a C benzene X, same thing will happen. That will also form that benzene cations plus X negative, 1 electron will be taken, and then the form radicals. The 2 radicals combine together and they form that toluene. Correct? So the things will happen like that. Now the same procedure will be happen for fatigue reaction also. Fatigue reaction, same thing will happen. What will happen by fatigue reactions? See that, students, that there is a benzene X, 2Na, X, again benzene, and we will take the dry ether. What will take? Dry ether. What will happen? That will form the benzene and the benzene. Now the point is, the same mechanism means what? Again, benzene free radical plus again benzene, that will form the free radical, which will combine together and form the benzene and benzene. Correct? So this compound is going to be formed like the phytic reaction. Now we talk about that third is the Ullaman reactions. You can see that Ullaman reaction is a same thing will happen in the presence of copper. Suppose we have the iodobenzene here. Okay, 2 moles. When we talk the copper and heat, that will form the biphenyl. So compound will form the biphenyl. Suppose one more example is that iodine and 2 moles here is a CH3 in the presence of copper and heat, that the form is benzene, and here is the benzene, CH3 and CH3 will form. Correct? Similarly, if I ask you that here is that iodine and the nitro group, 2 moles, copper and heat, that form the compound will form like that NO2, and here is that NO2. Am I right? So basically, exactly what will happen? Copper 2 moles, when we take the Cu2 plus 2 electron, and the 2 benzene is here, that CH3. Any group you attach, don't break this group, don't enter anything, don't do anything with this any substitutions. Only you break. Here is a free radical will be will come there, and same things here a free radical will form, and the 2 compound will like that. This compound will form like that. So what happened? These things is going to be formed. Correct? Now fourth is that a frankland reaction. Frankland reaction. Frankland reaction, what will be happen? See that the Frankland reactions exactly alkyl halide. Now I'm going to the all we have done through the free radical mechanism. This one you understand through the ionic mechanisms. That you can see here what is going to be happen. G when we will take and heat, that will form the R and R. So how it will happen? See that Rx, that will break and form the R cations plus X negative. Zinc will lose the 2 electrons, that the 2 electrons will attack here, and it will form, what will form? That R negative. Correct? Now this R anions will attack on Rx, correct? And they form the RR plus X negative, X negative, X negative, and Zn2 plus. What will happen? Zn(x2) will. Correct? So I hope you understood this whole 4 reactions, chemical properties of the aryl halide, which is so easy. Okay? So I hope you understood. Have a nice day. Thank you for watching this video.